Hello everyone, welcome back to my YouTube channel. Today we are going to discuss some problems on block diagram reduction. So I have written our first question that we are going to do today. Here we have a block diagram which has one parallel path and three loops. So what I'm going to do is I'm going to identify the parallel path and the loops. Then what I'm going to do is I'm going to figure out how can I reduce step by step. So first of all, I'm going to start with the loops and the parallel paths. So I have a parallel path G4 over here. Okay. And when it comes to loops, we'll start with the innermost loop. We have H2 as the innermost loop. Okay, it is going like this. Okay, it is a loop, innermost loop. Then there comes H1, but it is not as a loop inside loop. It is somewhat like a loop in between two loops. So what I'm gonna do is I'll reduce in such a way that there will be a huge loop and all the other loops comes within that one. That's what I'm gonna do here. So here H1 is also there and H3 is also there. Okay, and if you take a look at the summing point, here we can say that the summing point looks like plus and minus. So from this we can say that the closed loop will have a transfer function in the form g by 1 plus gh. That is, we know that if h is minus, then the equation will have positive. If it was the other way around, if it was plus, that is, if here it was plus, then the equation will be g by 1 minus gh. Okay. So that's what we'll be doing next. So I'm moving on to solving this given question. So first of all, what I'm going to do is I'm going to check whether there is a proper parallel path or not. Once I take a look in this, that this and this two branches, but are they actually parallel? They would have become parallel. They're actually not parallel right now. They would become parallel if this takeout point is not present here. So what I'm going to do is I'm going to change it. I'm going to move it either ahead or after. So what I'm going to look into it. So if I move this takeoff point to this place, I'll have to move it like after a block and after a summing point. So it will be too much of work. So I won't be doing it. Then what I'm going to do next is I have another option. I can move this takeoff point to the other side. So here I'll just have to move it ahead of a block. So I'm going to choose that option. So I'm going to move that particular takeoff point ahead of that block. So it will be, I'll take this point and I'm going to take it here. So if I'm going to take it here, I'll have to divide this equation with the G2. Then only I'll get the same signal as I get here. So I'm going to draw it in the next diagram that I'll be taking this point to here, and that will give me a simpler circuit. Then we can solve the parallel paths and the series paths as well. So I'm going to draw it once again. This time I'll be drawing it with, so we have two summing point in the beginning, then we have G1, and that we have another summing point, then we have G2, G3, in parallel with the G4, this is summing point out here, and we have the output. From there we have, I think, H2, and we have H1, which we have moved to this place. So it is not H1 anymore. We have moved it from here to here, so it won't be h1 anymore, it will be h1 by, it will be h1 into g2, h1 into g2. So okay, I just said earlier that I'll be dividing with g2, but it's not actually division, it's actually multiplication, because the wave here, the wave that is flowing backward will contain g2. So if I am taking it here, it should contain g2, then only the answer will be the same. So I'm multiplying that particular equation with the g2, and I'm taking it to the takeoff point here. Okay, now we have the outermost loop, that is h3. Okay, now we have drawn our block diagram once again. Here we can see that the G2 and G3 are in series. G2 and G3 are in series. So their answer will be, if the blocks are in series, we will multiply them together. So it will be G2, G3 in single box. Okay, and that particular box, so I am drawing it here. If you are writing in a notebook, you have to do it again. G2, G3. I'm putting it in a box. Okay, I'm replacing the series as single box. Now we have G4 parallel to G2, G3. So what we are going to do is, if we have two blocks in parallel, we'll be adding them together. So I'm going to add G4 with G2, G3 because they are in parallel. So what I'm going to do is, I'm going to add them. So G2, G3 plus G4 will be the resultant. So I can just replace this entire block with a single block, that is G2, G3 plus G4. So I'm going to remove all the loops, and I'm going to write G2, G3 plus G4 as a single block. Okay, so that's it. We are done with our first step. We found that there were two series blocks and we solved it. Then we found that that particular block is in parallel with another block and we solved it as well. And we got a single block. Now what we are going to do is, we have to get it. There are three loops, right? This one, and this one. We have to get these three in such a way that all the two comes within the biggest one. So here H3 is the biggest. It contains H2 and H1. But I want it in such a way that the H2 is the most innermost loop. H1 will be the second one. Then H3 will be the outermost one. So I want it in that particular way. So in order to get that, what I'm going to do is, I'm going to move this takeoff point to this place. That is, all the three loops will have the same takeoff point. So in order to make that, I'm going to move this takeoff point to the final point. So in order to do that, what I'll have to do is, here this signal does not contain this particular term. But if I move this takeoff point to here, it will contain this term. So I have to avoid this term. So what I'll be doing is, I'll be dividing this particular equation with this term. Okay. So it is very simple. So that's what I'm going to do next. I'm going to change the takeoff point. So it will look like, I'm going to write it. So there will be two outermost loops, and then we have G1 in between, G1, and we have another loop. Then we have G2, G3 plus G4, and from the outer we have three loops, right? So this is how it's gonna look. Now we'll write one by one. We have the innermost loop, that is, let me check the question again. Okay, it has H2 as the inner loop. Okay, that's fine. So it is H2 here, same as before, no change. But here it will be it was H1G2, but as I moved it from here to here, it will be, what will it be? It will be H1G2 divided by G2G3 plus G4. So that will be a block. Okay. Then the outermost one. We have the outermost one, that is the H3. Okay. Now I'm gonna solve them one by one. I'm gonna solve each of the loop one by one. I'm considering the innermost loop. I'm starting with H2. So in order to do that, what I'm going to do is I'm going to solve this loop. We know the closed loop transfer function, so I'm going to apply that equation. That is, I'm going to apply the equation G by 1 plus GH. Here this box represents G, and this box represents H. So what I'm going to do is I'm going to solve it like that. Okay, so it will be, I'm going to replace this entire block with the equation that we get, that will be G2 G3 plus G4 divided by 1 plus G2 G3 plus G4 into H2. Okay, I'll get this in this place. Okay, I'm gonna replace that loop with this particular value. So I'll get this block over here. I'm just gonna draw it right here because we don't have to draw it all over again. So I'm gonna draw this thing right here, G2 G3 plus G4 divided by 1 plus G2 G3 plus G4 into H2. Okay, I'm replacing it as single block. Okay, now we have solved our innermost loop. Now we'll move on to the next loop, that is the H1G2 loop. So first of all, we are going to look into this. We see that this block and this block are in series. So what do we do with the series blocks? We usually multiply them. So I'm going to multiply G1 with this block. So it will be G1 into the value in the particular block. So I'm going to replace the whole thing as G1 into whole thing. I'm gonna replace. Okay, so now we have come down to our second last stage, that is we are gonna solve the second inner loop. So I'm gonna solve this loop. Okay, in order to do that, I'll use the exact same equation I used earlier, that is G by 1 plus GH. Okay, so what I'm gonna do is I'm gonna take G as this term and H as this term. So it will be G1 into G2 G3 plus G4 divided by 1 plus G1 in 1 plus G2 G3 plus G4 into H2. That is the G term divided by our equation on applying 1 plus GH. So I'm writing G here first. Into the H term. The H term is H1G2 divided by G2 G3 plus G4. Okay. On solving this, we can say that we'll get the reduced block of this particular loop. I'm going to solve this equation. I'll be getting, I can cancel these two terms. So I'll get this term over here and I'm going to multiply this with the 1. So I'll be getting G1, G2, G3 plus G4 divided by 1 plus G2 G3 plus G4 plus H2 divided by this term I'm going to multiply with 1, so it will be 1 plus G2 G3 plus G4 H2 plus what is left here, that is G1 H1 G2 whole divided by 1 plus G2 G3 plus G4 into H2. So what I'm going to do is I'll cancel these two. So it will be finally G1 into G2 G3 plus G4 divided by 1 plus G2 G3 plus G4 into H2 plus G1 H1 G2. It's not over yet. Okay, it's not over yet. We have one more loop to solve. That is, we have H3 left to solve. We have to solve this one as well in order to complete our answer. So yeah, that's the only thing that's left. We have solved this and we have gotten a block. So we have one more loop to solve. So we'll do the same thing as before and we'll get the answer as G by 1 plus GH. So I'm gonna write the answer itself. It's same way again. That is, I'm gonna write the numerator first, then the denominator as such. Then we'll have an additional term, that is the numerator multiplied by H3. I hope this is the answer. We'll check it afterwards. So okay, so this is the final answer that we will be getting after solving this. This will be G1 G2 G2 plus G3 plus G4 into H3. Yeah, this will be our final answer after solving this entire block exactly using the same equation. Okay, so by that we can write the entire block diagram as we can write the entire block diagram with an input R of S and an output. There is no place, so I'm writing output. Okay, this is how you reduce a given block diagram into a simple block diagram. Okay, I've reduced this given block diagram to a single block diagram. Okay, this is one question and it has taken so much time. So practice will help you reduce your time while doing this problem on exam. So thank you so much for watching. If you like my video, please like and subscribe to my channel. Thank you.